All right, so I think we're at the beginning of week 4 now, right? So week 4. All right, so for those of you who have been keeping up with stuff and checked Module 4 out, this week is this is the week to let me know if I'm going to be going too fast or too slow. It's also the week if you've fallen behind, this is when you need to tell me in order to get back on track to getting a really good grade on the course. It's not impossible to like have completely had a lot of issues in the past couple weeks and completely recover and turn that around. It's just after that week, it becomes a matter of trying to help you to make sure that you pass the course, right? And again, the wrong time to let me know that you've been having issues the entire semester is right before the semester ends. If you're having issues, if you're having difficulties that are preventing you from succeeding in this course, you need to let me know sooner rather than later. There's a lot of stuff I can do, okay? In my graduate course, 5016, I had a student who basically had a lot of issues with the bursar and wasn't even sure that he'd be staying in the class. So he didn't really do much work during the first 2 weeks. So we came up with a schedule, since that's now been resolved, since he now knows he's going to be taking my course, and he's going to be back on track. So the entire point is, again, if you speak to me, I can help you out here. Now, we're going to be dealing with loops this week, as well as turtles. You'll notice that I've talked a bit more about turtles here, as well as talking about indexes and how they relate to different operations, right? So, Lab 4, notice that it also says it's Lab 4 and 5. So, this week's lab plus next week's lab is combined into one mega lab. And this is typically because I used to, I would actually used to hold the exam during week 5. That's normally my goal, but I've said week 6, and I'm sticking to that. That might mean that I add if statements into the mix there, but that's okay. The point being is that this is the one that either, there's basically a few outcomes for this. One, students pace themselves and they just basically take it slow and steady and have no problem with it. Students already basically cram on this and they get it done very quickly, or students struggle and put it off. So those are basically the three ways this work. And if you're having trouble with it, don't put it off. Please come to me so that I can explain things to you. Because we're not just talking about, because not only are we working with loops, but we're also working with functions, right? Now, functions we don't really go into too much detail for the first exam, but they're so useful for making sure that you can separate your code into small subprograms that they're worth giving you a small taste, as I say, for them. I put that in as a first taste of functions, right? And you want to get that done as soon as possible. That explains functions, but I'm going to go ahead and explain them over here before we go into our exercise for the day. So I've mentioned this before, but I've used this phrase before, but it didn't necessarily mean anything yet. But when we write functions or procedures in a programming language, that is the equivalent of adding a new verb to the language, right? Functions essentially are verb. Functions in other programming languages are sometimes called procedures. This is a very old term, procedure, or process, or the subprocess. The most common word for function, though, besides function, is a weird one, which comes from the object-oriented programming world, which is method. You'll hear me use that term method, but that's just basically a function in an object-oriented programming context. I don't know why we call it that. I haven't looked up the etymology for that, but that's what we sometimes call it. Python, it's very easy to add a new word or a new verb to our language, a new function. Okay, it's basically got 3 parts. It's got function declaration, name, arguments. So First part, function declaration. Def. Def is short for define function, or just define. That is where we're declaring our function. Basically, we're saying hey Python, get ready. I've got a new verb for you. Then we've got the name, okay? The argument and the colon. Pass. Okay. I'll go through that in order. Okay? Name can be whatever we want it to be, but that's the name of our function. Okay? So I'm going to call this one say hello, because that's what I'm going to do. I'm going to write basically a super basic function to begin with, okay? Which is just going to print out hello world for us. I know that seems really redundant, but I promise I'll expand on that in a bit. Then you have parentheses. Notice, if you remember how we've been doing print has open parentheses, close parentheses. There's some other things that I showed off, like sum. Also, whenever we make our turtle do things, like move forward or backwards, right? Those commands all end with parentheses, right? Those parentheses are basically part of what makes us saying we're actually performing this verb. Here we're just defining it, and I'll get into what we can put in the parentheses in a bit, but we use what's inside the parentheses as parameters. Okay? Pass, that just simply means that, so this is just a quirky word in there because of the indentation system. When you hand in your code, there should never actually be any pass or a line that says pass in it. I'm just including it because I included it in my homework. See, in my homework I have some functions like let's say, if that basically say that are like this: draw square, and I won't list them out. Draw arg1, arg2, arg3, whatever. Doesn't matter what the args are. I'm just calling them. And if I run this, nothing happens, but a good kind of nothing. Okay. Functions 919. Okay, a good kind of nothing happens here, right? Nothing happens, nothing crashes. Okay, if I go print hello, prints out hello. Awesome. Now, if I remove this pass, this line that says pass over here, which would have happened if, and why would this happen? Because my homework has some example code headers for you to copy in, and if I didn't put in the pass, this is what would happen. You'd paste it in, you'd test the code, and it crashed saying, and this is hard to read at this distance, so expected an indented block after function definition on line 4. Meaning that whenever we indent something, be it with a for loop, or an if statement, or a function definition, whenever we say with a colon that there's an indentation coming, it expects you to put something indented there. And pass basically allows us to put in an empty line that's indented so that the program can continue. Basically, it's a to-do, okay? So now we can now let's go ahead and work on say hello. So say hello, just simply say, I'll make it simple. Print hello. That's it. Whatever's inside the function is indented inside of a function, just like whatever's inside a for loop is indented inside a for loop. This is all we need to define a function. So next, what we do is, hold on a second. Next, what I do, I'm going to go ahead and call the function, as it's called. Or sometimes we use a bit more of a fantasy word, invoke. I invoke the function, right? It does sound more, fantasy RPG when you say it like that. But call, the formal definition is invoke, but I mean like call is one syllable, so you'll hear most people say call. So say hello. Now, if I just simply write say hello, it's not going to do anything, right? Because that's actually just the name of the function. I'm not invoking it. I'm not calling it. In fact, if I print say hello, the name, if I print the name, it's going to print out, it's a function called say hello, right? So to actually invoke it, you use the parentheses, like that. That's why we use the parentheses, to say we're actually running the function. We're not actually trying to mess with the function itself. And there we go, print hello. And if I copy this, if I make changes, like I copy this a few times, like, and now I make it say 3 hellos like that, one line does that invocation. Now, sometimes you have a lot, so you'll find you're sometimes going to be writing that it's easy to break a program into multiple parts, and sometimes those parts are really unchanging, like say hello. This doesn't change. Every single time I run it, it's going to print out the same number of hellos. But in your program, but in your homework for the programs, I'm going to be like, oh yeah, I want you to run, the first part of it is write a program that prints out the song 100 bottles of beer on the wall, right? The entire lyrics from, 100 all the way down to 1. I mean, or your beverage of choice, it doesn't have to be beer. But I also say maybe I want to start at 50 or 10 because it does take a while to print out. So what we can do to alter the way that a function works and make it work differently each time it's invoked is by having a parameter. We've seen this when we have a turtle and tell it to move forward one distance or another distance, right? It doesn't move forward the same distance. We provided a number and it moves forward that number. So what we do is that we can put in a variable name over here, an argument, okay, or parameter. There's a formal definition between argument and parameter. There's actually like one is what you do here and one is what you do here. I'm currently in the middle of writing a textbook, and literally this is the only time I remember, and I have to look at my own textbook to remember which one is which. So if you confuse argument and parameter, don't worry, everybody else is too. So nobody cares. So anyway, what we can do is we can add a variable name here, like num times. Maybe I want to do say hello, and the objective now is I want hello to repeat not 1 time or 3 times, but number of times. So we can modify our program like so. Okay? And I'm going to create a deliberate error outside of the function, but don't worry about that. For in range num times, print hello. Okay, and that's all we need for for say hello. I'll go into it in a bit more detail in a second, but if I run it now, I'll crash. No, and it's not a syntax error. This is a runtime error. Syntax error is when you never even get to running the program because basically your interpreter goes, that's not valid in Python. That's not part of the Python programming language. So here it's saying type error, say hello, missing 1 required positional argument num times. So here in say hello, I've added a num times over here, but I didn't put anything over here. So this kind of acts like one way we think about the arguments is that they're a contract, which is saying, hey, if you give me this argument, I'll be able to use it to do something, but you have to give me that argument. So because I didn't provide anything for num times, it crashed because it's like, I need this knowledge to work. I have to print it out, hello out, a certain number of times. If you don't tell me how many times, I can't use it. So we solved that by, oh, okay, we need a certain number of times, I'll put in a certain number of times, 5. So the 5 gets copied over into this variable and then gets used over here. For blank in range 5, print hello. So for loop that repeats 5 times, what does each loop of the for loop do? It prints out hello. Okay? So, right? if I told it to print 100 times, it would do that quite easily. All right? So this is the format of a lot of your programs in in Lab 4 and Lab 5. One common mistake I see is that I want, my programs ask the user for input. So for instance, I might say, hey, if this was a homework assignment, I might say, hey, write a program that takes in the user, that asks the user how many times they would like the program to say hello to them and print out hello that many times using a function. And what I mean is for students to do something like this. Input, right, equals, sorry, not input equals, but n is equal to input int, just going to do it in one line. How many times do you want the program to say hello? It doesn't really matter what text we put in here. It really doesn't. But there we go. Second, and then we have the second. So we have 2 open parens, 2 closed parens. And then we put in n over, and then we take this number, put it over here. And what happens is that we copy this information into num times. So notice that the variable names don't need a match, right? Because what we're doing is we're copying the data from here and putting it into here. And so now if I run it, and I put, how many times do you want it to say hello? I say 4. It prints it out a bunch, and it prints out 4 times, right? Now, one of the things I like to say, tell students is that the input should be the last part of the program. It's actually the least important part of the program. Yes, we used it a lot in of the other programs, but that was because that was the only real way we had to communicate with the program. Okay? So, in fact, that's the last part you put in because you can test your code a lot quicker when you don't have to enter in what you want it to compute. You just run it. Okay? So where's the mistake I get? The mistake I get is a lot of times I see students do something a lot like this. Rather than, they'll have this or whatever on the outside, they'll pass in some information from the outside to the function, and then they'll put the input inside here. They'll say hello num times, and then they say num times is equal to this number. So they'll put the num times over there. Now the reason that this is a mistake is because now the function is harder to test. The function itself is harder to test because every time you run the function, it asks for the user input. Also, this entire argument is now obviated. It's made obsolete. It's unnecessary. Because whatever we put in, it's automatically getting over, the user's just going to go and overwrite it. It's a very common mistake. Don't put input inside the function, okay? The input stays outside the function. Your function should be, your user interaction should be kept outside of the function, outside of your functions as much as possible. Make sense? Now we go into this in plenty of detail again for exercise 4 and 5, as well as the first taste of functions. But writing functions are extremely useful. Right now, we're only concerning ourselves with writing functions and passing in parameters to them. Once we address them again later, we'll learn about return. Right now, we're learning about arguments where we put things into functions. Return, which is another part of this, allows us to get things outside of functions. Okay, and the reason we need that is because we need functions maybe to communicate with other functions. And they can't communicate by using the text output. I mean, maybe they could, but that would be overcomplicated to do that. Like, I'd have to go jump through a lot of hoops to be able to read my console output and make sure what I read was what I wanted to read when I wanted to read it. So Functions are important. They help you break down big problems into a lot of smaller problems. All right. So with that, I think we've got, we are going to go ahead and work on our current exercise. So once again, open up Runestone, go all the way down to the bottom to Project 5, generating a password Xkcd style. Or if you need to find it otherwise and you're on Canvas, you can just simply click on Module 4, and click on the link that I have up on Tuesday, which will pull up the exact exercise. Make sense? So either way, I'll let you get to this page. Let's see. Let me pause first. So so this is something our Temple's IT department actually gets right. In fact, our IT department's pretty darn good. They have very sensible policies. So here is a comic written by, from Xkcd. If you're not familiar with Xkcd, it's a very it's a comic with a lot of math and science jokes and esoteric jokes. And this one is talking about specific ISO standards. Pennsylvania wiring, but New Jersey and Delaware adapters, right? So, okay, which are apparently things. So anyway, there's this, with passwords, we have, every company, website, whatever, has policies with regards to what your passwords should be. Typically, it's something like this. You need an uppercase letter, a lowercase letter, a symbol, and a number, right? You need those 4 kind of classifications of characters, and then it needs to be 8 characters or more long, depending on it is. So you've got some base word like troubadour here, and then you've got common substitutions, capitalization, maybe not capitalization, and then you add in some random stuff on the end. Okay? Long story short, for your password, that's about 28 bits of entropy is what he puts it at. And when this came out, that was about, if you guess 1,000 passwords a second, that's about 3 days worth of guessing. We'll go into this in more detail as to how that's calculated. But the point being is that when you're trying to crack somebody's specific password, isn't necessarily too bad. Implausible attack on a weak remote web service. Most of the time, most websites don't store your actual web address. They don't actually store your addresses. They don't store your actual passwords. They store the hash of your password, which just simply which is basically, it says, well, we're going to throw your password in through a numeric kind of randomizer. It's going to basically just simply kind of methodically and deterministically randomize all the bits in there, and we're going to store that answer. And so when somebody puts something in that's wrong, we can check it against that number. And when you put in you're right, if you get the same number, great. It's actually pretty cool. It's not really something you have to worry about at the moment. Okay? But the point being that it's easy for the computer to guess and hard for the user to remember. Was it a trombone? No, troubadour. And was the one and one of the zeros was O a zero, and then there was some symbol, right? Remembering this is a pain. Whereas that if you choose 4 common random words, correct horse battery staple, that actually has more entropy, more randomness in it, which takes centuries to guess. And so it's hard for a computer, and the difficulty to remember it is that you've already memorized that it's correct horse battery staple. It's not exactly hard to remember 4 words like that. The average ability of a human to memorize things, like random things in a group, is around 4 to 7 things, is basically what we consider pretty easy to do. Just memorizing a string of 4 to 7 unrelated stuff. If it's related, you can memorize tons of stuff. Through 20 years of effort, we've successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess. And so the Temple has actually, IT's department has a policy where if you can, the longer your password is, then you can just, you can use less special characters. In fact, if you use like 16 or so, you can just use lowercase letters. It's pretty good. It's pretty sensible. All right. So let's start by creating some random passwords composed of numbers, letters, and a few special characters, right? This is what your password generator program does, something like this. Now, because we're talking about creating a random password, what are we going to need? We're going to need a library, right? What library do we need? Not a trick question, random. Yep, we need the random library. Import random. Now that was in, I think, the readings part, that was part of the readings from last week. So all those functions. Now, the random library in Python is amazing. It's fantastic because it makes a lot of things easy. Generating stuff from random is pretty good. You can do like random.rand int, and I think, let's see, does 5 work? I forget. It's all different in all the languages. Rand int takes 2 arguments. Oh, right. It needs 0 to 5. Okay, and this generates a random number between 0 and 5. So inclusive. This is the only time where the endpoint is inclusive in programming. Okay. 4, 3. So it just changes there. But more importantly, for the purpose of of what we need to do here, is that we've got a function called random.choice. And that is something that we want basically in every language, but Python's just got it, and it's wonderful. Random.choice letters. So notice over here we have 3 variables. We have letters, which is all the lowercase letters. We have caps, which is a string of all the uppercase letters. And we have numbers, which is a string of all the numbers. If I do random.choice letters, it will select, well, it's not going to look like it does anything because I didn't print anything out here. Again, got to print stuff out. So now if I run it again, we see U, M, N, Q, D, C, E, E, A, O, W, K, Z, H, P. Now these are independent events. Each one is as random as the next one. So yes, of course we're going to get repeats. That's randomness for you. Okay? We can have an entire philosophical discussion as to, well, okay, first off, random is, they're statistically random. They're not truly random because you can calculate what it's going to be if you know how the math works and what the starting seed is to generate those random numbers. So it's considered pseudo-random. Now, whether anything is truly random is left to the philosophy class, because you could make the argument for a 6-sided die. If I roll that, if I know the exact forces that are put into that, and the way the air is in the room, and the way the ball, I could calculate how the dice is going to spin, and therefore what face it's going to land on, right? The only thing you can really say is that a 6-sided die will never land on a 7, except when it does, which is inconvenient. There are ways. They're unusual and grotesque, but you can get a 6-sided die to roll 7. But regardless, the letters are. So anyway, we can choose something at random. It's statistically random. For computer science, we don't care. It's close enough. So here, what we want to do is make an 8-letter password by combining characters from the 3 strings, right? So, okay. So we're going to need a for loop to repeat stuff, okay? And we need random.choice. So take 5 minutes to use this tool to create a new to create a tool, and when I run it, it should come up with a password, okay? Now there's a cool little trick involved in here that you may not pick up on, and that's okay, but it'll make sense when I show it to you. So take a few minutes to do that. All right, this is going to be one of those things that once you see it, it's kind of obvious, or at least the beginning of it, once you see it, it's going to be very obvious. All right, so let's go ahead and call this cars maybe for whatever, and I'm going to just simply make that equal to letters plus caps plus numbers. All right, it's a bit weird to think about it, but you got to remember that this is a tool you can use. You can add strings together, which just simply is concatenation, which is a fancy way of saying you can glue strings together into one mega string, right? Okay, now that we have this, instead of doing random.choice for letters, we can do random.choice cars, and that will work for any character. There was a 5 there, a Y, and now a Y. And now we need 8 of these suckers. Okay, if I want to do something 8 times, I'll do a for loop. For blank in range 8 to do it 8 times. And most of you got here. Or I saw a lot of people who got here and they're like, I'll run this. And now we've got 8 random letters printed vertically. Now the next question, of course, is how do we actually get it as one string? Now there's a couple different ways to do it. There's actually 2 legitimate ways to do that. The first way is explained as part of the beginning of Lab 4 and 5 on the PDF, which is to modify the way print works. You can change the way print decides to end the character. So by default, when you print something, it goes on to another. You go on to another line. It ends with a new line character. You can instead say, I want the print statement to end with anything. So in here I could say end with I want everything to end with a space. And now everything is separated by a space. Or you could say I want it to end with nothing. And then it's all one. So that's one way to do it. It's also not the way I initially thought to do it. But it's one way that you may have thought to do it. Modify the print statement, and that's a valid answer. Another way to do this is to use the accumulator pattern we learned from week 4. From project 4. Now remember, we use the accumulator pattern to do a running sum, right? Add 1 plus 2 plus 3 plus 4 plus 5 and store it in a number. But turns out you can do the same thing for a string. So this is one of the things where once I show it to you, it's kind of like, how did I not figure that out? And it's because you haven't thought about how to apply the tools like this, or hadn't had the opportunity to think about how to apply the tools like this yet. Password is equal to and then empty string instead of 0, right? And what we'd simply say here, nothing's really simple. We say password is equal to random.choice. That would just simply take one character and store it in password, and then take another character and store it in, and it would overwrite. So instead what we're going to do is we're going to say password is equal to password plus an additional character. And then what we'll do is we will print out the print out the password over here. And there we go. It prints it out. Now, we did this with strings, okay? Not too bad to do this with strings, okay? But now that we see it, there's a couple, we kind of get the idea of how to do this, okay? Now, let's go scroll down to the next one, okay? Keep this one in mind, because this is definitely a case of, okay, as above, so below. So now, let's go ahead and work on making the Xkcd style password, where we take 4 random words and store them and basically put them into one password. You can separate them by spaces, or you can not separate them by spaces. It's fine, either way. But now, normally we'd say, okay, where do we even get the words from? They're provided here. Normally, though, you have something on your computer called a dictionary file. I used to know where they were stored on Macs, but you do have a file that basically just has a list of of words that are valid in the English language, or in another language, because spell check works in other language too. But the entire idea here is that you can use that as a list of valid words. Now, what I would do is I'd also, make sure that those words were trimmed down. So this one, we've got a list of nouns, a list of verbs, and a list of adjectives. Lists. I haven't really talked too much about lists. Well, the fun thing to know about lists is that they work exactly the same in terms of operations as strings, which is fairly unique. In other languages, they're treated as totally different, and Python's like, nah, they're both sequences of stuff, so we can treat them both like sequences of stuff. You can add them together. You can use indexes in the same way. The only difference is that basically the first letter in letters is A, the second is B, the third is C, right? Or index 0 is A, index 1 is B, index 2 is C. Here, the first thing in the list nouns, index 0 is tissue, index 1 is processor, index 2 is headquarters. So basically it's an entire thing as opposed to one letter. But otherwise it works exactly the same as a string does. It's just a more abstract collection of things. It's one variable that holds a lot of stuff in it. Okay? So now we want to make a 4-word password by combining the lists above and selecting things from them. So go ahead and take a stab at it. It shouldn't be too bad now that we've kind of got a pattern worked out. Okay? All right. Any other questions about that? Totally wasn't recording that last bit, sorry. So again, the password just gets updated each time with the previous value of the password. Okay. This time it was empty string plus decrease, then it was decrease plus status, then it was decrease status plus represent, then decrease status represent plus warm. And the space again, ignore the space, I just threw that in there for readability purposes. And if you're curious, this is pretty much how I do my passwords, where I just choose some random words and just simply make it a very long, and as a result, because they're random words, it ends up being a lot of characters. All right, so most IT departments, though, they aren't as awesome as Temple's IT department, right? Where they let you make where they make it so that the more characters you use, the less complex it has to be, right? The idea here is, though, that we can replace, so we can automatically kind of make some differences here. So there's some string operations that are introduced in this paragraph. Okay, the first is using the replace method, which replaces one string with another. So pool.replace the O's with the E's gives us peel, right? That makes sense, right? Replace is fairly straightforward. Replace this substring with a different substring. Okay. Once you and then so we could do so we could make all those boring changes that we hate doing anyway. I feel like it kind of loses the plot here having to do that, since it was all about avoiding doing those. The other thing it points out is capitalize. You can use capitalize to print stuff over here. So here's that is in context. So we start out with pool. We do word.replace O with E, print word. And we notice its word is equal to word.replace. If we don't have this word equals over here, and we just simply do word is equal to pool, and then we don't do an assignment statement, we just do dot replace, it's going to still be pool. Now the reason for this is an important fact that you're going to need to remember about strings. Strings are immutable. Immutable. That is the formal term for that. What I'm really saying is strings cannot be changed. You cannot change a string ever. Just doesn't happen. Don't know why. Don't know who came up with that rule, but you just can't. Okay. So anytime we do an operation that seems like it's changing a string, like replace or capitalize, what we're actually doing is that we're using the old string to generate a new string, and then we're storing the new string if we want to use it. Okay, you can't change strings, but you can use them to generate new ones. It's a weird thing, but I figured I might as well let you know about that to begin with. Peel, and so you can make some changes there. Go ahead and run that. This last part's actually the more exciting part that I find interesting. All right, so this one is one that I'll go over primarily. We'll take a look at it and we'll explain it. But let's suppose that we do have a 4-character password that's only composed of lowercase letters. Okay? We have a 4-character password that's only composed of lowercase letters. So in other words, randomly selecting 4 things from this. Okay? How long would it take to guess that? And so why not write a program that does that tries to crack a random 4-letter password? Now, in most websites, you can't really do this because it locks you out. Like if you've ever tried to unlock an iPad that wasn't yours, right? It will give you it will start slowing you down, right? Saying, you've had too many bad password attempts. Okay? So here is the program as it stands now. Import random. We know that one. Import sys, S-Y-S, short for system over here. System.set execution limit 60,000, which they comment is 60 seconds, so we can kind of infer, make a nice, good, educated guess that the 60,000 here, the units is milliseconds, right? In physics and chemistry, they always make you write down the units. You never have to write down your units in computer science, but then you realize, wait, that was kind of maybe a good idea. We're going to have a password call. We're going to just go ahead and set the password. We're going to choose it to ABCD. It could be anything we want, though. And then we have guess number is equal to 0. So that will initialize. While done is equal to false. So this is so done here is what we call Boolean variable, meaning it's got 2 values, true or false, right? Here it's false, false in being not true. They could easily be, 1 or 0 or whatnot. Here's true or false. So it's saying while, and now on line 7 we have an example of the other kind of loop that Python has. It's not a loop you have to concern yourself with for the first exam, but it's the while loop. For loops are what we call determinate loops. We like to use for loops for whenever we have a very good idea of how long it's going to run. And we use, like when we say over here, for I in range 4, that's determinate. We know exactly how long it's going to run. Here, though, we're working with a while loop based off of randomization. It's indeterminate. Pretty much you use while loops whenever you've got something that you're going to run, and you're not exactly sure how long it's going to go for. A lot of times that's because you're running it under user input. Here it says guessed password is equal to this, and then if guessed password is equal to my password, print found it after this many tries, done is equal to true. So what this does is that this while loop says while not done. So done is false, right? Once you say not done, not false, that flips to being true. So this, and while statements run so long as this thing over here, its condition is true. So when done becomes true, it becomes while not done, which would turn that into false. So because it's false, it would stop executing. Basically, while loops run so long as the condition is true. Makes sense, though. While not done, do this. Oh, now that we're done, we are going to stop doing this. It makes it for some easy reading, which honestly is very useful. So now, what do we do in order to guess the password? Well, we've kind of got the idea here. We know how to generate short random passwords, right? So we've got my password, and we've got guessed password. And if they're equal, then we found the password. So guessed password is equal to this. So how can we generate a what do we need to do here to generate a 4-letter password? You don't need this over here. What do? We need letters, right? Let's go up. Let's go and be lazy rather than typing them out. Let's go ahead and copy the letters variable that they've so generously provided us. Paste it here. Okay? And then say for in range. And then we need 4 of these guys. But guessed PW is equal to random dot choice. Now here we're just going now this is a very dumb way to guess passwords because it's completely random, meaning that because it's completely random, we could sometimes guess passwords we've already guessed before. Okay? But it's short enough that that's not going to matter. Okay? For this, and then the other thing we're going to do is that when we change our, guessed password, what am I missing here? Right, this only turns it into 1 letter. Yes? Yep, I'm missing the increment. I'm missing the concatenation. Guessed password is equal to, I've got 4 letters, and I need to be a 4-letter password that, long. Another way to do that, by the way, again, as we learned, there's a shortcut, plus equals, which just means add this on to the end of that. A lot easier to write, right? So we've got our guessed password, we've got our letters, and then do the following 4 times. Concatenate a random letter to the end of guessed passwords. Okay? And now, one last thing, guess underscore num plus equals 1, which is the same as saying guess num is equal to guess num plus 1. That just increments it by 1. So let's go through this loop and understand what it does before I run it. Well, actually, let's go through the code again. because there was one thing over here that I forgot to mention. The sys.set execution limit to 60 seconds. This is if you've written some bad loops, you may have noticed that your web browser, that the program crashes after a certain amount of time, right? In Runestone. In Runestone, if you run a program and it runs too long, it's just going to automatically crash. This is to protect your web browser, or to, so that your web browser doesn't lock up. So you don't like accidentally have to close your web browser and like lose a bunch of work that you were doing, So here, this sets that limit to for how long this can run to 60 seconds. Oh. So now we've got the password we're trying to guess. We've got the guess number is equal to 0. While it's not done, set guessed password equal to empty string. Now the reason this is here rather than outside is that we want to reset it each time we go through the loop. So again, there's a lot of stuff that's all at once. And again, I mentioned like a lot of this isn't going to even be pertinent to the exam. Letters is equal to A, B, C, D, right? Over here, that's our letters. Choose a random letter, add it to guess passwords, increment our guesses. Run it. Well, if we find our password, print out, I found it after guess number tries. So we'll see if this works. Could take a while, but it hasn't done it yet, which is indicative that I might have messed something up. Let's go ahead and see. Let's see, plus equals guess number. Let's see, so, nope, finally found it. It says it found ABCD after 189,157 tries. So that is how basically, it took less than a minute for it to figure out how many there were. Now, this last one over here this last one over here, this last code block I'm going to use to do some calculations. The question is, how many passwords did it actually have to go through and try? Well, actually, let's pull up idle. Here, this is a good use of idle being a calculator. Actually, so let's see. Okay. So how many letters are there in the English alphabet? There are 26. And the first position can be one of 26 different characters. The second position can be one of 26 different characters. The third position can be one of 26 different characters. And the fourth position can be one of 26 different characters. So it's 26 times 26 times 26 times 26, meaning that there are 456,976 different four-letter passwords. Okay. On average, we'd expect to have to go through about half of them before we hit the right one, right? About half of them. We'd have to expect to go through half of them on average. Sometimes we find it a bit earlier, sometimes we find it a bit later. We did almost 200,000 guesses in less than a minute. Okay? So the idea here between those for those passwords, okay? So another way to write this, by the way, is 26 to the fourth power. So if we make this a 8-letter password of all lowercase numbers, it becomes even bigger, right? Becomes 26 to the 8th power. That's a lot. That seems like a pretty big, and that is a pretty big number. That is thousands, millions, billions. Okay? It's 208 billion possible different combinations. But for a computer, that's easy. Not only is this an easy task, it's a parallelizable task, meaning that if I throw 5 computers at it, it's going to take go 5 times as quickly. They can tackle the same problem. Okay? Now, on the other hand, though, most of the time we're not restricting ourselves to undercase letters. It's undercase letters, 26 plus uppercase letters, 26, plus numbers, which is 10 or so, 10 digits, and then we've got symbols. Let's call that another 10, because some are going to be used, some really aren't going to be used, whatever. This is for illustrative purposes only. So there's 8 random characters essentially chosen, which means, and that brings that up to trillions, I believe. Hundreds, thousands, millions, billions, 722 trillion. So yeah, that's a lot of guesses for the computer. It's a lot for your computer to work through. But humans are kind of bad at understanding the power of exponents. Our example here of a 16 of correct horse battery staple. Correct horse battery staple, that is 7, 5, 12, plus 8, 20, 21, 22, 23, 24, 25, 26 characters long. We'll be generous and ignore the fact that there are spaces in there. So 26 characters long. 26 to the 26th power is extremely massive. Long passwords, even on a restricted character set, is intense. Heck, if you want an even more clear illustration of it, just restrict yourself to digits. 10 to the 26th power. That's literally 10 to the 26th power. That's a lot more combinations than your hundreds of trillions right there. These numbers eventually get to the point where they're so big that the human mind has trouble comprehending how big these are. The part of the reason we use logarithmic scales for things like for things like earthquakes, because the amount of difference between the amount of difference in that the zeros add eventually just make our eyes kind of blur. 1 to 10 we can understand, but that's huge. These, even though these look less complex, they are huge in comparison. All right. So he points, and whoever wrote this textbook, whenever they wrote it, their MacBook Pro averages around 16,300 guesses a second, right? So it doesn't take too long for, right? If he only has to take, and then he says, how long does it take to crack an 8-letter password with only letters, uppercase letters, lowercase letters, and 10 possible digits? So that would be uppercase letters plus lowercase letters. So that's just 62 to the 8th power, right? So divide that by 1630, he said. Sorry, 16,300. And we've got that number, which that's seconds, divided by 60 to get minutes. Divide that by 60 to get, that's minutes. 60 to get hours, 24 hours in a day, 365 in a year. So 424 years to crack that, which seems bad. But just remember, he's only using one MacBook. And this is what we call a parallelizable problem. So, in other words, he could crack it in a year if he had 500 MacBooks. Most people aren't running these kind of programs on a dinky little laptop. Your MacBook's great, but it's still a dinky little laptop in comparison to like what desktop computers can do, because of this way that laptops are meant to deal with heat. They don't do sustained processes for so long like this. But this is certainly within the realm of possibility if you want to crack the password of somebody that, your organization doesn't like very much. So keep that in mind. Use very long passwords where possible. All right. So I hope you had a good weekend. And I'll see you all on Thursday.